Linear inequalities and absolute value inequalities. Let's review our symbols for less than and greater than. The less than symbol almost looks like an L that's just been tilted over a little bit. That might help you remember which one is the less than. And if it has the line drawn underneath the symbol, then that includes equal to. In previous courses, when you've graphed a number on a number line, you probably used an open circle for the plain less than or greater than, and a closed circle if the equal to was included. But in this course, as a transition to some higher math, we'll use parentheses when we have just a plain less than or greater than, and brackets for less than or equal to, greater than or equal to. Also, what will be important on our number line graphs is what happens when you go forever to the right or forever to the left. When you go forever to the right, you're going towards positive infinity. And when you go forever to the left, you're going towards negative infinity. We will be representing inequalities in 3 different ways. The first way is inequality notation. And that is when you have the little actual greater than and less than symbols. So we're going to look at -3 is less than x is less than or equal to 10. So the value of x lies in between -3 and 10. And it can include the 10, but it cannot include the -3. The second way is a number line. And so on our number line, because the x is trapped in between the -3 and 10, our graph is trapped in between the -3 and 10. The -3 has a plain less than, so we put a parentheses on the -3. The 10 has an equal to included, so it has a bracket. Interval notation also uses the parentheses and brackets, and you look from left to right. The leftmost number is where your graph starts. The rightmost number is where your graph stops. So our graph runs from -3 to 10, parentheses on the -3, bracket on the 10. The instructions say to write in interval notation and graph on a number line after we've solved it. I think it's easier to graph on the number line first. So once we solve for x, that's what I will do. I want to solve -5x is less than or equal to 30, so I divide both sides by -5. And we need to remember our rule with inequalities, that when you multiply or divide both sides by a negative, your inequality symbol flips. So the result will be x is greater than or equal to -6. Now let's put that on a number line. So here's -6. And if it's greater than -6, all the numbers bigger than -6 would be to the right. So I'm going to draw a graph to the right with an arrow indicating that it's going on forever and ever towards positive infinity. And because I have the equal to as part of my greater than, I need to put a bracket on the -6. So that's number line. And then interval notation, remember, is where you list from left to right the start and the stop. So from left to right, the graph starts at -6, and then it continues on to infinity. There's a bracket on the -6. Infinity always has a parentheses, because you cannot equal infinity, and bracket indicates equal to. So infinity, positive and negative infinity, always have a bracket. Now we're going to solve 18x plus 46 is less than 12x minus 8. Let's get our x's together, so we'll subtract 12x. 6x plus 46 is less than -8. Now subtract the 46. 6x is less than -54, and divide by 6. I'm not dividing by a negative, so my symbol just stays the same. And x is less than -9. So that's the solution. Now let's graph it on a number line. -9, x is less than -9, so everything less than -9 would be to the left. going forever towards negative infinity. There is no equal to on my less than, so I put a parenthesis on -9. Now interval notation, from left to right. The leftmost number this graph is going to is negative infinity, and it stops at -9 on the right. Always a parenthesis on infinity, and the -9 also has a parenthesis, so that is interval notation. Now let's talk about absolute value. This little part is actually from section 1.6, but absolute value is the distance from 0 on a number line. For example, if I want to look at the absolute value of x equals 4, that means the distance away from 0 is 4 places, and you can go to the right or to the left. So if I go to 4 to the right, I land on +4. But if I go from 4 to the left, I land on -4. So either one of those numbers would solve that equation. Whether x is +4 or x is -4, the distance from 0 is 4 on the number line. So when you're solving absolute value equations, you will always have two answers. And you'll always start by writing the equation twice. First equal to the positive value, and then you'll write the word or, and then again equal to the negative value. So we want to solve the absolute value of 2x minus 3 equals 11. We need to write this twice. First, 2x minus 3 equals positive 11, then the word or, 2x minus 3 equals -11, and then we just solve those two equations. On the left side, add 3. 2x equals 14. Divide by 2. And x equals 7. So that's one answer. Then the one on the right, add 3. 2x equals -8. Divide by 2. And x equals -4. Absolute value equations always have two answers. Write it twice. First equal to the positive, then equal to the negative. If the absolute value is not by itself, you need to get rid of all the numbers that are around it, just like you were solving for x. So I need to get rid of the 2 and the +3. The +3 would go first. Subtract 3. 2 times the absolute value of 3x minus 2 is equal to 14. You cannot distribute the 2 in front of the absolute value. You cannot distribute into those bars. I need rid of the 2. It's right up against absolute value, which means multiply. And to get rid of multiply, we divide. The absolute value of 3x minus 2 equals 7. Now that the absolute value is by itself, I can write it twice. First equal to +7. 3x minus 2 equals +7. Then the word or. 3x minus 2 equals -7. And then I just solve those two equations. The one on the left, add 2. So 3x equals 9. And divide. X equals 3. The one on the right, add 2. 3x equals -5. And then divide by 3. And x equals -5/3. Now, going back to section 1.7, let's look at a problem where we have the absolute value is less than a number. So we're saying the distance from 0 is less than 4. So that would include to the right of 0 all the way up to 4. That distance is less than 4. And then on the left side as well, all the way to -4. And so it's everything in between -4 and 4. My less than does not have an equal to, so I want parentheses on those numbers. So the way you show everything in between -4 and 4 is you write -4 is less than x is less than +4. So x is in between -4 and +4. And it's always less thans when you write the in-between sentence. If I wanted to write that in interval notation, I would do parentheses. The start is -4, the stop is +4, parentheses. Again, the parentheses because we don't have the equal to part on this problem, on the less than. So if it's a less than with absolute value, the x goes in between the negative number and the positive number with less thans. Let's solve absolute value of x plus 3 is less than 4. The x plus 3 goes in the middle, -4 on the left, +4 on the right, and we use less thans. So the x plus 3 is in between -4 and +4. Now when we go to solve that, I want the x by itself. So I subtract 3, and I have to subtract 3 from both the +4 and the -4. It's like two problems in one. Then we'll have on the left -7 is less than x is less than 1. Let's graph that on a number line and also write that in interval notation. So on a number line, from -7 to 1, the x is trapped in between, so my graph is trapped in between. Less thans without the equal to, parentheses. Interval notation, from left to right, start and stop. The left is -7, the right is 1, and parentheses. Another less than problem. The 3x plus 5 goes in the middle. -17 on the left, +17 on the right. This time we have equal to, so less than or equal to. So 3x plus 5 goes in between -17 and +17. Now to solve, we'll subtract 5 from the middle and from both 17s. So we have -22 less than or equal to 3x less than or equal to 12. And divide everything by 3, leaving us with -22 thirds less than or equal to x less than or equal to 4. On a number line, -22 thirds and 4. The x is in between, so our graph runs in between. We have the equal to's, so we need brackets. Interval notation, farthest left is -22 thirds. That's our start from left to right, and then on the right is 4. That's our stop, and we have brackets this time. That's interval notation. If we have a greater than with our absolute value, we're saying the distance from 0 is more than 4 away. So if it's farther than 4 away, that would be out here, headed towards positive infinity, and then on the left side, beyond 4, going to the left, headed towards negative infinity. And in this example, I have an equal to, so I'm going to use brackets. So those are distances beyond 4 away from 0. The way you would write that in interval notation, you need your start and your stop. So it's broken into two parts. That means we'll write two intervals. The farthest left is negative infinity, and then it stops at -4. Always parentheses on infinity, and the -4 has a bracket. Then the other part from left to right starts at +4 and heads forever to infinity. Bracket, parentheses. Because I have two parts, in the middle we use a U for union, and that means both of these sections are part of the answer. So when you have a greater than, you end up with x is greater than or equal to positive 4, you also have x is less than or equal to negative 4. So you would write that x is greater than or equal to positive 4, or x is less than or equal to negative 4. Just like with the equal to absolute value equations, you write it twice, the first time with the positive, the second time with the negative, and the word or in the middle. But it's greater than the positive, less than the negative. So let's solve this one. It's a greater than. When you have a greater than, you have to write it twice, just like when you have an equal to. So I write x plus 3 greater than or equal to positive 4, then the word or, x plus 3 less than or equal to negative 4. And then you have to solve each one of those. So the one on the left, subtract 3. X is greater than or equal to 1. The one on the right, subtract 3. X is less than or equal to negative 7. Now let's do a number line and interval notation for this problem as well. If it's greater than or equal to 1, greater than 1 would be to the right towards positive infinity, and I do have the equal to, so I need a bracket. Numbers that are less than negative 7 would go to the left towards negative infinity, and again, a bracket. So there's the number line. Now interval notation. From left to right, start and stop. From left to right, negative infinity to negative 7. Always parentheses on infinity. The negative 7 has a bracket. The other section from left to right starts at 1 and goes to positive infinity. Bracket on the 1, parentheses on infinity, and a union in the middle. Let's do one more. It's a greater than, so I want to write it twice. 5x minus 2 is greater than positive 13, or 5x minus 2 is less than negative 13. Solving the one on the left, we're going to add 2. 5x is greater than 15. Divide by 5. X is greater than 3. The one on the right, add 2. 5x is less than negative 11. Divide by 5. X is less than negative 11 fifths. Number line. Greater than 3 would go to the right towards positive infinity, and we have parentheses this time because we don't have the equal to. Less than negative 11 fifths would go to the left towards negative infinity, and again a parentheses. Now interval notation. Left to right, start and stop. From left to right, it goes from negative infinity to negative 11 fifths, parentheses on both. The other section, left to right, goes from 3 to infinity, parentheses, and a union in the middle. So in general, if your absolute value problem has a less than, that's the in-between type of problem. The value in the absolute value sits in between the negative on the left, positive on the right. If your absolute value problem starts off with an equal sign or a greater than, that's when you write it twice. First with the positive and then with the negative.